framework layers. Dependency to service interface as post. See. Hello everyone. Very warm welcome to Think Constructive. I am Isha. In this session, I will be building Java REST API using Spring Boot, Spring Data JPA and MySQL. So we will be building end-to-end CRUD operations or Java REST API using Spring Boot as a framework, using Spring Data JPA libraries, and will be persisting data in the MySQL database. After building the application, we will also be doing the thorough testing of the application with the help of Postman tool, and we will also be checking databases with the help of MySQL Workbench. So stay connected, watch the session till the end so you don't miss upon on any of the point. I have also given the GitHub repo link in the description box. So if you want to take that code, please go ahead and clone that code from the GitHub. All right, so let us start with the session. So let's have a quick recap of Spring Boot, Spring Data JPA and MySQL. Let's start with the Spring Boot framework. So Spring Boot framework is highly self-sufficient framework. It gives inbuilt so many things that makes developers' life very, very easy and building application a lot faster, very efficient. All right, so multiple benefits that it actually makes developers' life easy, development cycle very fast. So when I say it is self-sufficient, that means it must be having a lot of things inbuilt already, such as application servers. So if you are building a Spring Boot application, you no need to worry about, integrate application server from some other sources and do stuffs. Rather, application servers comes inbuilt with Spring Boot, such as Tomcat, Jetty, Undertow. It also has many starter dependencies. So for that also, no need to, developer need not to worry about anything. Rather, things will be given by the Spring Boot itself. Now let's talk about Spring Data JPA. With the help of Spring Data JPA, it has become very quick and easy to connect Java applications with databases. With the help of these libraries, developer need not to worry about writing a huge big code in order to establish the connection with the database. Rather, that can be just done with the help of some configurations, some annotations, and by extending certain interfaces. All right, so all those things we'll be seeing in a while. And then the third thing is MySQL. So MySQL is open source database, rather relational database management system, and it is very easy to use and highly scalable. That is precisely the reason MySQL is used by many small application as well as enterprise level applications also, such as YouTube, Facebook. All those, big product companies are also using MySQL. So it's so powerful. All right. So that's about Spring Boot, Spring Data JPA and MySQL in a nutshell. All right. Now let's see the scenario which we will be building. So in this session, we will be building Cloud Vendor API. All right. So in that Cloud Vendor API, Cloud Vendor properties will be this. So this will be our, model class, and the similar table with respect to Cloud Vendor will be created in our MySQL database with all these 4 properties. All right. So in Spring Boot, we will be building Cloud Vendor Information Service, which will be interacting with the database. In our case, it is MySQL. So this is the place. Cloud Vendor Information Service will be communicating with database, and from here you can see it will be also interacting, or rather exposing, the REST APIs. Get, post, put, delete. Majorly we'll be working with all those 4 APIs. We also call them as CRUD operations. So create, update, read, delete. And further, these requests will be sent by REST client to Cloud Vendor Information Service, and this service will be returning the response back to the REST client. All right. Now I will further elaborate what all layers will go in the Cloud Vendor Information Service. Okay. So here it is. In Cloud Vendor Information Service, we will be majorly building 3 layers: controller layer, business or service layer, and database repository layer. In simple terms, we also call it as a Spring Boot project architecture. So that is a typical architecture you will be seeing while building the REST APIs with the help of Spring Boot. That's how the layers will be divided typically. All right, so the first layer will be the controller layer. This controller layer will be interacting with REST client with all these four operations: get, post, put, delete, or the CRUD operations. This REST client can be your Postman, the tool which is used actually to test REST APIs, or the browser windows, whichever HTTP browser based operations are supported. So that browser can also be used to send those operations or those requests to controller layer, or it can be any user interface application. So any application can be called as REST client, which can send REST request and get the response back. All right. So that's what is REST client. Controller layer is the layer which is responsible to accept REST request and response back. All right. So all the REST APIs exposure will happen here. At this side, this controller layer will be talking to business layer. In simple terms, you will keep on listening this service layer term also. Okay, so this controller layer will be talking to this service layer or business layer. As the name indicates, business layer, that means any business logic which you wish to write for your project should go in this layer. And further, this service layer will be talking to the database layer, or this database layer is also called as repository layer. All right, so that means any database related operations will be performed in this layer. And finally, this layer will be talking to database. Here in this scenario, it is MySQL, but yeah, generically it can be any database. All right, so this database will perform the database operation, whatever is triggered by this repository layer. Once that operation is performed, this database will send the response back to repository layer. Repository layer will send the response back to service layer, and service layer will send the response back to controller layer. And finally, this controller layer will be responding back to REST client. All right. So that's how this entire functionality will work. So this cloud vendor information service, which is typically my Spring Boot application, is divided into these three layers, and these three layers will perform all the application logic together, persist data or query data from the database, send the response back to the REST client. All right. So this is the typical Spring Boot project architecture for REST APIs. All right. So now this is what we are going to build in today's session. Okay. Before starting the demonstration, I would just like to tell you this controller layer we have already built in our previous session. That session link is given above here in the card section also, and also in the description box below. So whichever way you want to use the link, please go ahead, click the link and make use of that video if you haven't yet watched that already. Okay, and also I have given the GitHub repo link in the description box so you can get the complete project from there. Okay, so this controller layer we already have, but I'll be doing certain changes and will be explaining few things there as well. So stay connected, and I would suggest, rather I would highly recommend, make your systems ready and try out all these things with me. Okay, so let us start with the demonstration now. So I'll first tell you how you can initiate the Spring Boot project and integrate all the required dependencies. All right, I'll do it with the help of a Spring Initializer. All right, so you'll just go to Spring Initializer website and you'll get to see the window like this. You can choose Maven or GetAll project, whichever build tool you would like to use. Language as Java because we are building Java project. Okay, Spring Boot version 2.7.2 should be good enough. Now in the group we can write whichever group ID we want. So in my case I will be writing Constructive. Okay, then artifact as I want to give it as REST demo. Okay, description demo project for a Spring Boot should be fine. Packaging, I want to select it as a packaging jar. You can opt for war also, and depending upon whichever Java version you would like, you can choose between 8, 11, 17 or 18. So I'm going ahead with 18. Now the important part is dependencies. So I should be adding whichever dependencies I would want for my project. So I'll just click on the dependency button, and first of all, I'll be selecting Spring Web dependency. Okay, because this is important for building RESTful web application or RESTful API. Another dependency for my project I'll be needing is JPA. So Spring Data JPA. I'll choose this, and one more dependency I would want. I'm going to use MySQL database, so I'll be using MySQL driver. All right, so these three dependency for today's session I'll be needing. I have selected all these three, and now I will go ahead and say generate. The moment I will say generate, it will generate and give me a zip project, restdemo.zip. In our case, I have got. All right, so this zip we should extract and load in any Java editor of our choice. Okay, in my case I will be using IntelliJ IDE editor. You can use any Java editor of your choice, whichever you are comfortable with. Okay, here is the IntelliJ IDE editor. I have loaded my REST demo project, in which we have already built the controller layer in our last session. Okay, so let's first have a look on the pom.xml. So whatever dependencies we have selected, we should get a pom.xml like this. In this, you can see Spring Boot starter dependencies are selected like this. Then group ID is com.thinkConstructive, artifact ID REST demo, version, name of the project, description of the project, all these things, and see Java version is selected like this. Fine. Now our web dependency is here. The Spring Boot starter web dependency. Fine. We need two more dependencies, which I have just shown you, JPA and MySQL. All right, so I'll be including those two dependencies here. So I'll be including JPA and MySQL dependencies here. Okay, like this. Why am I doing it manually here? Because I have loaded my last project, REST demo controller project, in which we have built CRUD operations without database operations. All right, and now I will show you how we can evolve and enhance that project. Fine. So I have just now included my Spring Data JPA dependency. You can notice here, Spring Boot Starter Data JPA. This is the Spring Data JPA dependency. And another dependency I have included as MySQL connector. Fine. So these two dependencies are important to connect my Spring Boot application to the database and do the required operations. Fine. Now I will just show you where is my controller layer and what all we have built in our last discussion. So here is my REST demo application, the Kickstarter for a Spring Boot application. So here is my cloud vendor model. This is the one. So all four properties are here. Constructor and setter getters are also provided. Fine. So this is the model class we have built and the controller layer, cloud vendor API service. So this is the controller layer which we had built, and all four CRUD operations are here. Just that it is only giving you the hard coded values in response. Fine. You can notice here cloud vendor created successfully, and just we have initialized the object of this cloud vendor. Correct. No database operations we have performed here. Now we will evolve this application, connect it to the database and query the database. Fine. We'll see all this evolution of the application now, and we'll test it using Postman, and we will also check the data using MySQL Workbench. All right, so don't leave the session in between, otherwise your core concepts will be missed out. Now first thing we need to do is we need to configure the MySQL database connector. All right, so that this application can be connected to the database. How do we do that? We'll go inside resources. We can open application.properties. You can use application.yml also. Okay. I'll just add application.yml in this. Okay. and I'll just leave application.properties as is. So I'll be doing all the configuration related to databases inside application.yml, and we'll see the we'll test the connection. All right. So let's start writing the configuration stuffs inside application.yml. Okay. So Spring, then data source. All right. So inside a Spring, there should be data source. Then the next level is URL. Okay. So we'll be configuring 3 properties for data source: URL, username, and password. So I'll be first writing URL here, which will be consisting JDBC. Okay, because that is essentially required to establish the connection. Then my database name, which is MySQL. Then the machine IP or host name. So since everything is configured on the same machine and I'll be making everything up and running on the same system, so I'm using localhost. Then the port ID. So 3306 is the default port number for MySQL. If you have configured MySQL at any other different port, please make sure to keep that port. All right. Then cloud_vendor. So this is the schema name. So that means in your database, this schema you should have already created. So I've already created cloud_vendor. That is where I'm giving this schema name. Okay. And after that, use SSL, I am writing as false because I am not using any SSL certificate. Just in case if you are using that, you should be marking this field as true. Fine. So next thing, after URL, I should be writing username. Fine. So in my case, my username is root, and password, whatever password you are giving, you can, whatever password for username root or whichever username is for your database, you can give and respective password. Fine. And next property we will be giving for the JPA settings. Okay. So next property is for JPA settings. Fine. So I'll be writing JPA dot hibernate dot DDL auto. I'll be using. I'm going to use it as create. Okay. There are another option which is available as update also. So in case you want all the DDL operations should be considered as create, you can use it as create. Otherwise, if you don't want that, so you can go ahead with the update also. So this is also another allowed operation. Okay. So create or update, either one you can use. Fine. So these many configuration settings we should be doing in order to connect my application to the database. Make sure your MySQL database is up and running. All right. So I'll show you my database is up and running with the help of my SQL Workbench. So here is my SQL Workbench. And in this, you can see this cloud vendor schema is already created. Inside this schema, my tables are empty. So ideally, what am I expecting? My table should get created with the help of my Spring Boot application. Fine. So since my MySQL database is up and running, that is where I'm able to, perform, refresh or any other operation here. Otherwise, it won't show me all these schema. So this is the, indication that my SQL database is up and running. All right, so I'll go back to the editor now. Here we have done the required configuration. So now let us start our Spring Boot application. If it gets started successfully, that is an indication my application is able to connect to the database. All right. So now let us see our application logs. Test demo application started successfully. That means it is able to establish all the required connections successfully. Otherwise, it would have raised or given me some error here. Fine. Okay, I'll terminate the server now. Just one important point to remember, whenever you add any dependency in pom.xml, okay, you should do Maven rebuild. How do you do that? You'll just click on this Maven. You'll just click on this Maven window and refresh from here. it will rebuild all the dependencies. Fine. So we have done that. Now let us add entity here so I'll add entity annotation here and make sure it is coming from javax.persistence. Fine, because this javax.persistence belongs to my JPA. Let us add one more annotation here, which is table, because I want to give a different name to my table, which will be created in the database. Okay. So I have just used this table annotation, again javax from persistence, which is part of my Spring Data JPA. And inside this table, I will just give name is equal to whichever table name I would want to give. So I want to give cloud vendor info. So I want to create my table with the name of cloud underscore vendor underscore info. So that is where I have given this annotation. If I want the default table name should be used, so then there is no need to give this add table annotation. Okay. And in that case, what will happen? My table will be created with the help of cloud underscore vendor. Okay. So since I wanted a different name, I have chosen to give table annotation here. Now there is one more thing I will be using because I want to specifically annotate and tell to Spring Boot, this is my ID field. So whichever field I want to decide and give as ID field, on top of which I should be using at ID annotation, again notice from javax.persistence. Fine, fair enough. So these many changes I have done in my cloud vendor model class. Okay, and now when we'll be storing the data, you'll notice cloud underscore vendor underscore info table will be created in the MySQL database, and we will be able to see properties like this: vendor underscore ID, okay, vendor underscore name, vendor underscore address, vendor underscore phone number, okay. So now let's do another change. So we already have our controller layer. I'll just give you a quick walkthrough of this layer. We'll do required changes in this a little later. Okay, so my controller layer, I have given the class name as Cloud Vendor API Service. Mandatory part is it is annotated as REST controller. Fine, because REST controller will tell in Spring Boot application that this class is responsible to expose all the REST APIs. Fine. And the request mapping, I want all request mapping should start with /cloud vendor. Okay. Now I have created a get cloud vendor details method here. And important thing to note here, a get mapping annotation is used. That means whenever any get request will arrive, this method will get executed. Similarly, post mapping is annotated with create cloud vendor details. That means any creation request will arrive with post method. This method will get executed. For update method, which is typically put method, put HTTP method, if any request will arrive with that, since put mapping annotation is put here, update cloud vendor details will get executed. Okay. And last method is delete mapping. Okay. So in case any delete cloud vendor deletion request will come with HTTP method as delete, then this delete mapping, because of this delete mapping annotation, this delete cloud vendor details method gets executed. Okay. So I hope this much is clear. We'll be doing some changes to this class as well, but after doing all the coding related to our service layer and repository layer, we'll come back and we'll do the changes here. Okay. So stay connected. Don't leave the session in between. It will be very helpful for you. Let's now build the repository layer. So I'll just say new Java class. I'll actually choose interface, create repository. folder, and inside that I will give cloud vendor repository. All right. So I've added it to my Git because this project is getting synced up with Git. So after this session, you can get the complete code from my GitHub repo. I will now extend JPA Okay, make sure you get it from org.springframework.data.jpa.repository. All right. So this is the package inside which you will get JPA repository. This JPA repository gives you a lot of methods already. So you need not to actually declare or define many basic methods, such as if you want to save anything in the database, you are not actually supposed to define any save method here because this JPA repository already provides you all that. Okay, if you want to define any custom methods, that means which are not available in JPA repository, then you can write that custom method signature here, right? So in our demonstration, I'll be using the JPA provided repository methods, and those are actually more than sufficient. So I am not going to write any custom methods here, but yeah, if you need, you can always write that. And if you want to see how to do that, there is another session available on my YouTube channel, which is data persistence using a Spring Boot and MySQL and Spring Data JPA. Please refer that session. That will give you more details how you can define custom methods here and play around with them. All right. So with this JPA repository, I need to first give my model class name, which is cloud, or you can call it entity. So cloud vendor. So another argument will be the data type of my ID field. So for my ID field data type, what we are using is string. So I'll be writing a string here and let's check it. So I'll go inside cloud vendor and the ID field is the vendor ID and the data type for that, if you notice, is string. All right. So string I have given here. That's it. That's all you need to do in order to define your repository layer. Okay, so the next step is I will be writing service layer. So I'll again go to the top package here, that is com.thinkconstructive.restdemo. Inside this, I'll go ahead and say Java class. Okay, I'll write my package name as service dot cloud vendor okay, we'll just say cloud vendor service, and this will actually be the interface, so I'll be selecting interface here. Okay, I'll add it to my Git. So public interface cloud vendor service is created here. Okay, I'll be writing which all methods I want to have in my business layer or service layer. Okay, so first method which I would want to have is, and what that method should return, that method should be public, it should return a string, and method should be create cloud vendor. Okay, what this method will expect, it will expect cloud vendor entity. Okay, all right. Another method what I would want to have is public string update cloud vendor. Okay, and what I will expect here is again cloud vendor as an argument. Another functionality I would want to have is public delete. Okay, so again the return type would remain delete. Would remain a string, and I will say delete cloud vendor, and I will just say cloud vendor as my not cloud vendor. So delete cloud vendor will have vendor ID as argument, because on the basis of ID, we should be deleting any information from the database. So I should be giving here as string cloud vendor ID. Okay. The next functionality I would like to have is public. What it should be returning is cloud vendor object, and I want to write get cloud vendor method here. Okay, so I'll just say get cloud vendor. And how will we get the information for a specific cloud vendor? Again, basis on the cloud vendor ID. So I will just say string cloud vendor ID. All right. So these are the 4 important methods. Fifth one also I would want to have, which is to get all the available cloud vendors information. Okay. So how should we write that? I will just say public list of cloud vendors should be returning, right? Because there can be more than one cloud vendors also available in the database, and the object type will be again cloud vendor, because this is what the list I would like to return. And the method I will call as get all cloud vendors. Okay. And the argument will be nothing, because I want to fetch all the data from the database which is available for cloud vendors. All right. So no argument is needed. Whatever is available for all the cloud vendors in the database, I want to get everything here. Fine. So cloud vendor service interface is defined. Now the next step is to implement it. Okay. How do we do that? Again, inside this service package, I will create one more Java class inside impl folder. My Java class will be cloud vendor service impl, basically service implementation. All right. And again, I'll be adding this to GitHub, because my project is getting synced up with that. And here, this service impl should implement what? My cloud vendor service, which we have just now created, because that is an interface. So I'm writing implements cloud vendor service. All right. So it's giving me an error. Why? Because it has got so many methods and I haven't implemented any. So default implementation I am putting right now to get rid of from this error, and we will be now implementing each method one by one. Okay. But before before doing those changes, we should be getting the instance of repository here, because repository is the layer which is actually talking to the database. All right. So I will just instantiate cloud vendor repository here, cloud vendor repository. Okay. And we will be creating constructor for this. So what do? I'll just say generate constructor with this argument. All right. So repositioning is needed. Let me just go ahead and do it. Okay. So what we have done, we have just instantiated cloud vendor repository and created a constructor with this argument. All right. So that's enough to get this cloud vendor repository layer interacting with service layer. Fine. So now let us do something inside this create cloud vendor, so that it can actually create data in the database with the help of repository layer. How do we do that? We'll go inside this method, and what do we want? Whatever is coming inside this cloud vendor should be saved to the database. Correct? How do we do that? We will be using cloud vendor repository dot. It will give me so many methods. Currently, what do I want? I want to save this cloud vendor object inside the database. So there is a method called as save. Save what? Entity. So I'll be calling this save method, and we have already know this cloud vendor is an entity. So what do? I'll be passing this entity value here. That's it. So with the help of just this much line of code, your data via repository layer will be saved inside database. Fine, your data is saved. And let us change this return value to some good message. So success. Okay. Now update cloud vendor. So whatever entity value is coming here, that should get updated in the database. Okay. How do we do that? Again, make use of cloud vendor repository instance. So I'll be using this, and update is again saving something in the database. So I'll be using save method here, passing the entity as cloud vendor. That's it. Fine. After this, let us pass a friendly message back. Success. All right. Now I'll come back to delete. Let us first implement get. Okay. So get cloud vendor on the basis of cloud vendor ID, whichever we are getting in the argument. Okay. How do we do that? We'll make use of our repository instance, which is cloud vendor repository dot find. You can see the moment I'm typing find, I'm getting so many find methods. Find all by ID, or find by ID, find one, all sorts of stuff. So currently on the basis of ID, I would want to fetch the data. So I'll use find by ID. Okay. And whatever cloud vendor ID I'm getting, I'll pass inside this. Okay. And since it returns optional, so I'll call one more method called as get, which will finally give me the required value of the particular object. All right. So this is what we have returned. And finally, I am supposed to return this entire cloud vendor object, which is returned by this statement. Correct? So I'll, rather than keeping, two-liner statement, I'll just take it out from here and return that complete statement. Okay. Actually, this statement is returning the value of particular cloud vendor. Okay. So this object will be returned via this. Okay. So the next method is get all cloud vendors. How do we implement that? No condition, no restriction. Whatever cloud vendor information is available in the database, we should get them all. Okay. So what is it returning? The list of cloud vendors. So I'll directly do changes in with this return statement. So removing null, and I will again use cloud vendor repository dot. I'll start typing find. So you can see find all. And what will this return? List of cloud vendor. This is what we want. So I'll use find all method. All right. So this will be returning the entire list of cloud vendors back to the controller layer. Okay. Now coming back to delete cloud vendor. Delete is a sensitive operation. So be always very, very careful before using and before implementing this. Take, sign-offs from your product managers. Do they really want to have delete? And more specifically, delete all kind of operations should be used with caution. So be very, very careful. Okay, so delete cloud vendor. How do we implement that? It's going to return a string. Okay, so again, I'm going to use cloud vendor repository dot. Let's see what all delete are available. So we have delete on the basis of complete entity, or delete all by ID, or delete by ID. So what do we want to do? We want to delete a particular cloud vendor basis on the given ID. So this is what we will be using, delete by ID. Okay. And inside this, it is expecting the ID value. So I will be writing cloud vendor ID, because that's my ID field and it's coming here in the argument. So this particular cloud vendor ID, whichever we are passing here, will be deleted from the database, and I will return some success friendly message. So I'll just say success here. Okay. So what we have done now, we have implemented our business or service layer completely. We have implemented our repository layer, and so simple to do that. All right. If in your project there is a requirement to do extra operations or extra logic, you can enhance this service layer and put those extra business logics here. Okay. Whatever more business logic you are supposed to write, you should be doing this more logic, or I will rather do business logic here. Okay. So you shouldn't be, cluttering any other layer. Rather, you should be doing all that business logic here. Be very careful with that. Otherwise, in the long run, code gets cluttered and becomes very, very unmanageable. So be very careful with all these stuffs. Okay. So these are the 5 operations we have implemented here. So this is my service impl ready. Just one more thing, which is extremely important. Otherwise, it won't be recognized as service. We should be giving service annotation here. All right. So it will come from org.springframework.stereotype.service. Okay. So this annotation is mandatory, is must to be added here. To service interface, what all we have done: create, update, delete, get and get all for cloud vendor. And in the repository layer, we have just extended JPARepository by giving entity as cloud vendor and ID field data type, which is a string in our case. Okay. So what we have done, we have implemented our service layer and repository layer. Now coming back to controller, let me just do a little refactoring for this controller, because that will be, that will give you more clarity. So I will be changing this cloud vendor API service to cloud vendor controller. Okay. So this is my controller layer, cloud vendor controller. Let us see what all changes we should be doing so that this controller layer can seamlessly interact or communicate with service layer, and going forward service with repo and then the database. So entire flow will be completed. Okay. So let me first remove this cloud vendor instance because we don't need it anymore. Okay. And what we'll be adding here, we'll be adding instance of service layer here. Why? Because my controller layer is actually interacting or talking or communicating with service layer. Okay. So from here, we'll be sending requests to service layer, and we have already seen service is sending something to repository here. Okay. So we'll be doing cloud vendor service instance here. Okay. And we should generate a constructor for that. Not refactor, where is generate? Yeah. So generate a constructor with this argument. All right. Again, a little repositioning stuff. Yeah. So this is my service instance, and a constructor with this argument is created. Now I will be using this cloud vendor service. Okay. And with the help of this service, I will be writing different operations here. So inside get cloud vendor details, what this method is supposed to do, it is mapped with get mapping. That means it should be getting cloud vendor detail for the respective ID. Okay, because we are passing a specific vendor ID here. So what should I do? I will just take instance of cloud vendor service dot get. We have created get cloud vendor and get all cloud vendors. So what I'll be using here, get cloud vendor, and inside this I should be passing vendor ID. Okay, because we are getting vendor ID from here. Rather than doing it in to statement, I will be just changing my return statement directly. Okay. Fine. So this vendor ID should actually be mapped with this. That means in the REST request, whatever vendor ID is coming with the GET request should be taken here and should be passed here. Okay. So let us do those changes now. So for extracting this get mapping vendor ID from here to here, I should be adding one more annotation, which is path variable. Okay. And inside bracket, inside double quote, I will give vendor ID. Okay, so whatever vendor ID value is coming here, it will be used here and finally will be extracted in this. Fine. So this vendor ID will be used in order to get the cloud vendor details. Okay, so this is about get cloud vendor details. I would want to add one more method for getting all cloud vendor details. So let me just copy paste and do the required changes. This is for read specific cloud vendor details. Okay, and another one is for read all cloud vendor details. Fine. So reading all, what change I should do? First of all, I should change the method name, which is very important, isn't it? Get all. What do I want now? I want to get all the cloud vendor details. Get mapping should not have this vendor ID, okay? Because not any specific cloud vendor ID we are extracting now. So no need to have any vendor ID here, and then no need to have any arguments here. Fine. And with this cloud vendor service, now which method should I be calling? Get all cloud vendors. So it will return me the list of cloud vendor. You can see that highlighted one here. Okay. And definitely this method signature should also get changed. Okay. There you go. So this get all cloud vendor details will return the list of cloud vendors like this. Okay. So whenever the get request will come without any argument, it will return all the cloud vendors information whichever are available in the DB. Okay. Now, how do we create cloud vendor details? So let us do required changes here. So post mapping, annotation we understand now. It will help to get things created. Create cloud vendor details. Whatever is in the request body, that value should be used to actually get the things created. Okay. I will remove this statement and I'll make use of my cloud vendor service dot create cloud vendor we have just now created, right? So create cloud vendor, and what should I pass? The cloud vendor entity. All right, this one here. So with this, my service layer will call repo layer and will create value in the database. Okay. So the next thing is put mapping for update cloud vendor details. Update with what? With this request body values. All right. So I'll again remove this statement and what should I use? Cloud vendor service dot update cloud vendor method, right? With which entity? Whatever I am getting here from the request body, which is cloud vendor. All right. And it will return the success message. Now, how should I delete? Delete for a particular ID. So that ID is passed here. In delete cloud vendor details, I should be able to map this vendor ID. So how should I do that? I'll just use path variable and will give vendor ID like this. Okay. And then I should use cloud vendor service dot delete method we have just now created, right? And what argument will go? Vendor ID. All right. And it will return the message cloud vendor deleted successfully. All right. So that's how you should be creating your controller layer. There can be many other stuffs done here, but yeah, and that's how the flow will go. Okay. So now we have pretty much done all the required changes. So let me just bring up the application, test the database connectivity, and then we will see how can we test this with the help of Postman. Okay. So we'll be creating certain records and then we will be querying those records from the database, updating them and deleting them. Okay. So now I will go back to rest of my application because that is my starting point, and I will just say run. Let's see in the logs what is happening. So my application is up and running. No errors, no issues. Everything looks good. Okay. Now let us first check what changes have happened in our database with the help of MySQL Workbench. So here is a MySQL Workbench. Cloud Vendor schema we have already seen. Now let me just refresh and see whether we can see any table or not in this. I've just refreshed this Cloud Vendor schema. Inside tables, see, Cloud Vendor info table is created. Okay. Since it is just, we have just started the application and till now we haven't created any data. So ideally this table should be empty, isn't it? Let me just say select rows. See, vendor underscore ID is the first field. Vendor underscore address is another field. Vendor underscore name and vendor underscore phone underscore number is another. So all four fields are here without any values because we haven't yet created any data in the database. Okay. Now the next step, I'll just open Postman and will trigger some request. Okay. So here is my Postman tool and I have created some collection, some request here. So first one is a create. So here in this request, I have chosen method as post because I first want to fire create request. And then this is the URL localhost colon 8080 because by default, my Spring Boot application will start running on 8080 port and then slash cloud vendor because that is the request mapping we have already given. Okay. And inside this post body, let me first give vendor ID as C1. Okay, vendor name as vendor1, vendor address as vendor1, and let's say phone number as 5555. Okay, or I can just say 1. Okay, because things will remain, clear. This is my message body. Okay, and you can see I have selected here message body and here the format, data type format as JSON because that is the default data exchange format for REST applications. If you want, you can change and choose any other format, but that you have to give explicitly in your application. Okay. So I'll just send the request and let us see what happens. What message I have got? Cloud vendor created successfully. Okay. That means my create cloud vendor request is successful. Fine. Now let us go back to database, which is with the help of MySQL Workbench, and again run this select star from cloud vendor query. So what result we have got? C1, address 1, vendor 1, and phone number as 1. This is what we have just now triggered and data is created in the database. Okay. Now let us again go back to Postman and check the same vendor ID with the help of GetAll. How many records should we get? Only one, correct? So we have got C1, vendor 1, address 1 and 1. Similarly, we can test get by ID for vendor ID as C1. Okay. So URL again same /C1 we should be writing. I'll just say send. What we are getting? Vendor ID, vendor name, address, phone number as is, right? Now let us create 2-3 more records and check the database and then we'll see get by ID for variety of IDs and get all. Okay. So I'll just say vendor ID as C2, vendor name as vendor 2, vendor address as address 2 and vendor phone number as 2. And I will just say send. Again, I've got vendor created successfully. Okay. Now let us check our database. I will rerun this query. See, I have got 2 vendor IDs here, C1 and C2. Cool. Now let us test the same stuff via Postman, get by ID. C2, send. I'm getting C2. Yeah. And GetAll. How many records should I get? See, 2 records, C1 and C2. Good. Yeah. Let us create 2 more records. Okay. So C2, C3, address 3, vendor phone number is 3. Created successfully. I'll create C4, vendor 4, vendor address as, and vendor phone number as 4. Okay. I'll just send the request. Vendor created successfully. And one more, C5, vendor 5, address 5, and phone number also as 5. Okay. So now I have created 5 vendors. Okay. C1, C2, C3, C4, C5. Let us test them using MySQL Workbench first. I'll execute the query. See, I have got 5 records created here. Now going back to Postman, let us say GetAll. How many records should I get? 5, correct? C1, C2, C3, C4, C5. Now let us say get by ID. For example, let's say for C4 I want now. I've got it. I've got vendor ID C4, vendor name as vendor 4, vendor address as address 4, and vendor phone number as 4. I would like to update vendor 4's address from address 4 to London. Okay. So what should I do? I will call my update request. Okay. In update, I should give the complete message body. Okay. And in vendor address, from address 4, I should be writing London. Earlier we have seen for C4 we were getting address 4. Now I will change that. I have changed that address 4 to London, and I will send the request now. Let's see what happens. Cloud vendor updated successfully. This message I have got. Okay. Let us go back to our MySQL Workbench. Rerun the same query and let's see what happens. See, for C4, vendor address has changed from address 4 to London. This is what we wanted. We'll test the same thing via Postman also. So I'll go to get by ID. For C4, see this, I will fire the same request again. And this time in address field, I am getting London. All right. Now, let us test delete by ID. So let's say I want to delete vendor C3. Till now, vendor C3 I can see, right? Get by ID, let's say first test it for C3. I have got vendor C3 with all the relevant details. Now I would like to delete this vendor C3. For some reason, I don't need it anymore. So in my URL, I have given the C3 ID, method selected as delete, and I will say send. I've got the message cloud vendor deleted successfully. Okay. Now let us go back to database and see what has happened there. I will rerun the same query. What am I getting? C1, C2, C4, C5. No more C3 I am getting here. Test the same thing via Postman. Get by ID. See, C3 ID. Earlier we were getting. Now when I will say send, what is it giving me? It is giving me some error because it is unable to find the C3 ID. I'll be doing another session on exception handling. There I'll be showing you how can you give a good error message here or back to the REST client. Okay. Rather than getting, a generic or internal server error kind of message, I'll be demonstrating everything with a live example. How can you deal with the exceptions? Okay. So now, yeah. So for C3, no more data exists. I will again say GetAll. Earlier I was getting how many records? 5. C1, C2, C3, C4, C5. Now I should get only 4. Correct? C1, sorry. C1, C2, C4 and C5. Okay, so we have tested all the CRUD operations, including GetAll or FindAll or fetch everything kind of operations of our Spring Boot application till the database. Okay, so I will leave the GitHub repo link in the description box. If you want, you can, take that code. I would highly recommend you do this practice along with the video. It will be very, very helpful. All right. We wanted to build this application completely with controller layer, business layer, database layer, persisting everything to the database and getting them tested with the help of all the CRUD operations. All right. So, and we also have developed a Spring Boot project architecture with all these layers, all the important annotations, key discussions we have done. So what all we have covered in this session, we started with the Spring Initializer, how you can, start a new Spring Boot application with all the relevant dependencies. So with respect to this session, we have added 3 dependencies: web for RESTful, Spring Data JPA dependency, and MySQL driver. All right, in order to establish all that database connection stuffs. And we have taken our project, changed the control layer. We have added application.yml and we have done all the database related configuration there so that database connection can be established. We have done the repository or database layer so that it can actually have the required code to communicate with the database, and we have done the business or service layer coding, established the communication between service layer and repository layer, and we have done the required changes in the controller layer and established the communication between controller layer and service layer. So overall, we have covered all this, whatever is getting displayed on your screen right now. So with the help of this, we have implemented CRUD operations right from controller layer till the database, and we have tested database with the help of MySQL Workbench also, and we have tested the entire Spring Boot application with all the database values created, updated, deleted, and queried or fetched from the database with the help of Postman also. If you have any doubts, anything you would like to ask, please ask your questions in the comment section. Also, please mention which next session you want to see. I would try to plan that session and get back to you with new video on that, with the demonstration, whatever is needed for that session. Okay. If you like any particular part of the session, please annotate that timeline in the comment section, because that will be very helpful for everyone else also. Okay. Thank you everyone for watching this session. I hope you found it useful and you build up CRUD operations or Java REST API with the help of a Spring Boot and MySQL database along with this session. If you haven't yet done so, please go ahead and try out all those things. There are more sessions available on a Spring Boot, Java and Python on this channel. If you haven't yet subscribed, please go ahead and subscribe to the channel, share it with more and more people so that everyone is benefited and we grow together as a community. I hope you liked it also. If so, hit the like button and let's meet in the next session. See you in the next session. Bye till now.